Hey guys, we're back with the final paper in the 2018 Maths Sats for Year 6. Let's dive straight in. So, we're on the last paper now, like I just said. This is reasoning again. So in the Sats, you get 3 papers. The first is arithmetic, where you just give them some numbers and you have to do some maths. And the next 2 are reasoning, just like the last one we did, where you have to answer word problems, understand what's going on. There are multiple steps. You have to draw lines. You have to circle answers. You have to show some comprehension as well and some logical thinking, not just maths. So let's take a look at question 1 then. We're going to dive straight in. We have to write the missing numbers. So this is just a basic sequence. And what you'll notice is, though, there's only one place where we see 2 numbers next to each other. And that's here, 49 and 42. So hopefully you can notice straight away this is your 7 times table. If not, you can just work out the difference and figure out that that's plus 7. You know, 63 is in your 7s as well. So that does seem to make sense. So if we're moving up, we're going to add 49 plus 7, or the next in your 7 times table, if you're really confident with that, it will help, is 56, 63, and then we're up to 70. Just be careful, guys, going backwards. We have to obviously subtract 7. So the 7, multiple of 7 before 42 is 35. Nice and straightforward way to start. Just got to know your times tables really well. Next one, Adam chooses the colors for a new team shirt. The shirt has 2 colors. In this case, it's stripes. There are 4 colors to choose from: yellow, blue, white, and red. Write the 2 missing combinations. So this is an all possibilities question. You've just got to be systematic. So here are the ones that were given: yellow, blue, white, and red. Just for the sake of being quick, I'm going to write them down as letters. So yellow, blue, white, and red. We're given yellow, yellow, yellow. Now we're given all the options where we start with yellow. To be systematic, we could say yellow, blue. We could say yellow, white. And we could say yellow, red. Now we've done all the yellows, we're going to move on to the blue. So we could have blue. We've already done blue and yellow, so we don't need to go backwards. Blue and yellow's already been done. Now we're going to do blue and white, and blue and red. And then finally, now that we've done all the blues, so we've done all the yellows, we've done all the blues, we go to the whites. Again, we've already done white and blue. We've already done white and yellow. So there's just white and red left. And funnily enough, guys, once you've done the first 3, you don't need to do anything for red because you've already got them all written down here. You can see here white and red, blue and red, yellow and red. So those are the 6 options. Let's see which ones we're missing. We've got all the yellows, so we can tick off these 3. We've got blue and white, so we've got that one there. So we're going to go for blue, and the other option with blue was red. And then the final one was with white, and with white we put red. So guys, for this question, it's all about being systematic, okay? Go through, write them down. Look what I did here. I wrote down all the options, even though I was given some, because then I can work through and tick off the ones we've got. Guaranteed to get it right that way. So just be careful with those ones. Question 3. Here are 4 number cards: 2, 3, 4, and 7. We've got a riddle. We see lots of these questions in class. Let's take a look. Layla uses each card once. That's vital. This is where reading comes into this test, and understanding and making sure you read it carefully. Use each card once to make a 4-digit number. She places 4 in the tens column. Well, that's easy. 2, so that it has a higher value than any other digits. That's just a posh way of saying it's the largest place value column. So the 2 is going to go over here in the thousands, which is the largest place value column. Look what I'm doing as well. I'm going to tick the 2, tick the 4. The remaining 2 digits, so that 7 has the higher value. So if I'm picking between the hundreds or the ones, clearly the hundreds will be the highest value there. So the 7 goes here, and that means we're just left with the 3 at the end. Lots of systematic questions so far. You've just got to work in a system quickly, efficiently. You'll be fine. Question 4. I love these questions. Classic reasoning for addition. Let's take a look. Write these 3 missing digits to make this addition correct. And we always start in the ones column, and this is where the first trick comes in. 9 plus something is 6. Now that sounds outrageous. How can I add something to 9 and end up with 6? Well, we need to really use our brains here and think about when we do addition sometimes. 9 plus something isn't 6. 9 plus something has to end in 6. So can you think of a number that ends in 6 that we could get as an answer by adding something to 9? Yes, look. 16. Use the exchange. That's the problem here. 9 plus something is 16. Now that we can do. That's 7. Now we just need to be careful in the tens column, which is the next one here, because we have blank plus 2 equals 7. Apart from we don't. We've got the extra 1 at the bottom. So 2 plus 1 is 3. Now we've got 3 plus something equals 7. So we put 4 up here. 2 plus 4 is 6. 3 plus 7 is not 0. So again, you need to write in the exchanging here. 3 plus 7 is 10. So what do we put down here? 5 plus the one that we exchanged is going to give us a 6. If you really wanted to check this, maybe you finished the test and you're just going back, just do this addition now. Do it over here. And then you can see if it comes out to the same answer. Question 5. Tick the numbers that are common factors of both 12 and 18. Basically what we're saying here is 12 in the 2 times table as well as 18 being in the 2 times table. So you're looking for common factors, factors of 12 and 18. 2 does go into 12 and 18. 3 goes into 12 and 18. 6 goes into 12 and 18. 9 goes into 18, but it does not go into 12. And then 12 goes into 12, obviously, but it doesn't go into 18. So we'll leave those blank. Tick the numbers. This is key, guys. Read the questions carefully. Multiple. We knew it was at least 2, but be careful. Could be 3, could be 4. They might all have been multiples. I would also say don't do anything to the boxes. It doesn't say cross the boxes that aren't. Just tick the boxes that are. That's the safest option there. Question 6. This chart shows the number of different types of big cat in a zoo. There are 20 big cats in the zoo altogether. I'm just going to write that here because it might be useful as we scroll down. Here are some statements about the chart. Tick the statements that are true. Again, look, plural statements. There are more cheetahs than jaguars. Well, here are the cheetahs and here are the jaguars. And hopefully you can see there the cheetahs. We don't need to do any maths here. We can just see that cheetahs is a bigger chunk of this pie than jaguar. Cheetah is a right angle. Jaguar is an acute angle, so it's smaller. So this is absolutely true. Next one, excuse me. The total number of lions and tigers is larger than 10. Again, we can see here, tigers and lions, it is over 1/2. Imagine that's 1/2 there that I'm cutting. Half of 20 is 10. So half would be 10. Tigers and lions take up more than half. Therefore, lions and tigers is greater than 10. So it is false. It says here the total number of lions and tigers is 10. No, it is greater than 10. So that is wrong. Keep that blank. 1/4 of the big cats are cheetahs. Now, this is a fantastic question because look, like we've already said, the cheetahs, that's 90 degrees. And if you're solid with your angles, you'll know that we can fit 4 lots of 90 degrees in a full turn, a full circle. Therefore, cheetahs is 1/4. So that is a tick. We could fit 4 of those cheetah chunks to make the whole. So that is absolutely correct. Then look at the bottom one. There are more than 5 jaguars. This is false. I'll tell you why. Because again, using the same logic, if there's 20 in total, that means there are 5 cheetahs because 1/4 of 20 is 5. That means that this chunk here that I've kind of done a dotted line for already, this is worth 5. And you can clearly see jaguars take up less space than 5. So jaguars, there are fewer than 5 jaguars. Therefore, we leave that blank. Those are the 2 options. Next question, question 7. A farmer is packing eggs. Each box holds 6 eggs. The farmer has 980 eggs to pack. How many boxes can the farmer fill? Here is where we have to do short division. So 980, and we're going to pack these eggs into boxes of 6. So the top number now will give me how many of those boxes we have. 6 into 9 go once, 3 left over. 6 is into 38, goes 6 times. 6 6 is 36, that means there are 2 left over. And now you'll notice something. 6 is into 20. I've got just 20 eggs left. That means I can make 3 boxes, but I'm going to have a remainder of 2 eggs. So these 2 numbers here, I want to explain to you exactly what they mean. This number is how many boxes that we can fill. Look at my amazing picture of a box. Wow, that looks just like an egg box, right? Anyway, this number is not how many boxes are left over. That's how many eggs we have left over. Because the question asked, how many boxes can we fill? So we filled 163 boxes and we have 2 eggs left over. Now, why is that important? Have a look. How many eggs will be left over? That will be your remainder. So we're just going to stick the 2 in there. Very common question there, asking how many full boxes of something we can share, how many will be left over. It's really important that we practice those. Question 8. Jack has £400 and he spends 35% of his money on this new bike. Nice one, Jack. How much does Jack spend on his new bike? So this question is literally just asking us to work out 35% of 400. So as always, work out what 10% will be. 10% of 400 is £40. And once we've got 10%, we can work out any multiple of 10. So let's work out what 30% would be. 30% would be 3 lots of 10%, obviously. So 3 lots of 40 is £120. But be careful, the question did not ask for 30%, it asked for 35%. So we also now need to calculate what 5% would be. Luckily, we can still use this fact here. This 10% fact is going to be really useful for this question because 5% would be half of 10%. So 5% would be half of 40, which is £20. Therefore, if we want to figure out what 35% would be, we have to take 30% and 5% and combine them to get £140. That's how much Jack spent. That's 35% of 400. This is a really good question to see the difference between reasoning and arithmetic. In arithmetic, you would have just been given 35% of 400. In this question, it's just that bit trickier. We had to work out what to do ourselves. Question 9. The Angel of the North is a large statue in England. It is 20 meters tall and 54 meters wide. Ali makes a scale model. That means that it's in proportion. We don't stretch out one way without stretching out the other way. So it's in proportion of the Angel of the North. Her model is 40 centimeters tall. So let's take a look here. We're given 20 meters tall. Now, imagine for a second, ignore the units. Let's just make the numbers the same for now. If 20 meters tall, we wanted to turn that into 40, we would have to double the height. And if we're doubling the height and we're making a scale model, we have to double every dimension. So we doubled the height. We've also got to double the width. Double 54 is 108. Now, of course, these are meters and meters. We want it in centimeters, but that doesn't matter because the scale, the proportion between the numbers would stay the same. Even if this was 40 centimeters, we would still keep it up here as 108 centimeters. So if hers is 40 centimeters tall, it has to be 108 centimeters wide. That is quite a large model if it's 108 centimeters wide. But this is just scaling, guys, okay? And it has this question here, don't get your ruler out. That won't help you, okay? You have to make sure that you are working this out of a calculation. Question 10. Layla draws a square on this coordinate grid. 3 of the vertices are marked. Vertices are corners. This is a classic way of doing a square question on a grid because we often think of squares like this with a flat base. But of course, squares can be rotated. And that's exactly what's happened here. So we're given 3 of the corners and we know that they're right angles. But firstly, I'm just going to join up this line because there's something we know about squares. Each side is the same length and opposite sides are parallel. So this line, I'm actually going to use it to help me draw a line going up this way on this diagonal because I know it's going to be roughly parallel. And I'm going to imagine I've started here, I've gone across one, up one to the next diagonal. So I'm going to do the same down here. Then I'm going to count how many times I've got to do it. 1 time, 2 times, 3 times, 4 diagonals long. So I'm going to do the same down here. 1, 2, 3, 4 diagonals long. This is my missing corner right here. And if we look at the question, what are the coordinates of the missing vertex? We know it's right here because, like I said, guys, remember, sides on a square the same length and opposite sides are parallel. So if I wanted to, I could just finish it off like this and like this, but that's not what the question's asking. It just wants to know what this coordinate is here. It does go into the negatives. We go on the x-axis first, start at the origin, 1, 2, 3, so that's -3 back, and then how far up? Just 1. So we're going to go at 1 on the y-axis. -3, 1. Next question, 11. Stefan has 600 milliliters of water in a bottle. He pours some of the water into 2 measuring jugs. Question, how many milliliters of water are left in Stefan's bottle? This is testing you reading measurements. So if this line is 100, this is 200. Halfway between 100 and 200 is 150 mil. And over here, what's really interesting is we still have the 150 line, but it's just testing, do we know, okay, you know what's between 100 and 200? Do you know what's in between 50 and 100? Or in this case, 150 and 200. And this is just classic counting up in 25s, okay? So this would be 125, because that's half of 0 to 50. This is 175. So we have in jug 1, 150, and we have in jug 2, 175. We need to find the total here. Remember, show your method. Do that, guys. I promise you, it's worth doing. 150 plus 175, that's going to give us 5 in the ones, 12 here, exchange over, 325 mil. So he's poured out 325 milliliters, but that is not the question. The question is how much left in the bottle. Well, look here, he had 600 to start with. So he started with 600, and in total, he poured out 325. 5. Now, when you have two zeros like this, you may be more confident counting up from 325 to 600. It tells me to show my method. I'm just going to use the column method with some double exchanging. So once I've double exchanged here, I've got 10 take away 5 is 5, 9 take away 2 is 7, 5 take 3 is 2. There is 275 milliliters left in his bottle. Next question, question 12. We are whizzing through. Superb. This table shows the areas of the United Kingdom and Jamaica. That means areas as in maths. I was thinking then like the places, like London, Manchester. No, the areas, the total distance covered. Okay, the square kilometers. So UK is 240,000 square kilometers. Jamaica is 10,000 square kilometers. How many times larger is the United Kingdom? So basically what we're doing here is we have something multiplied by Jamaica, which is 10,000. So how many times larger? That's where times larger comes in. That's what would go in this box. Has to give us 240,000. Now, the cool thing is we can use our knowledge of dividing and multiplying by 10, 100,000, 10,000, 100,000. So here, something times 10,000 is 240,000. Think of it this way. 1, 2, 3, 4 placeholders in 10,000. So whatever we started with here has to be 4 placeholders smaller than 240,000. 1, 2, 3, 4. It actually gets rid of all of those placeholder zeros right there. And we could put 24 into this box. So it's 24 times larger. If you wanted to test it out, take Jamaica and multiply it by 24. See what you get, because it should be the same as the area of the UK. Next question, question 13. A box contains 2.6 kilograms of washing powder, and Jack uses 65 grams on each wash. He's now used all the powder, so how many washes did he do? Basically, we're asking here, in 2.6 kilograms, how many times can I take out 65 grams? So it's the same as thinking 2.6 kilograms divided by 65 grams. As always, get it into the same unit, 2,600 divided by 65 kilograms. Two ways to go about this, okay? You can use long division. So if you want to count up in 65s, you absolutely can. You can do it like this. You can lay out 2,600. You can divide by 65. And what you'd be doing down the side, which is the same really as the other way, you could just write down in 65. So one lot of 65 is 65. 2 lots is 130. That means 4 lots is 260, because you can double 2 lots to get 4 lots. And this is actually really important. If you know 4 lots of 65 are 260, you can put a 4 here, take away the 260, and actually you're left with nothing. And you bring down nothing, and you've got nothing. So you just put a placeholder in there. There are 40 washes in 2,600. The other method, guys, I was going to say was just to start with chunking and get to 4 lots is 260. So you know that 40 lots would be 10 times bigger, and that would get you to the 2,600. Whatever you're confident with doing, but look, show your method. Okay, this question was asking you how many times does 65 fit into 2.6 kilograms? Why is this question hard? Because you've got to do some converting and you've got to choose your method. You've got to divide by 65. That's not easy, guys, but you will have learned this for sure, especially when you're prepping for your arithmetic paper. Question 14. 2 of the angles in a triangle are 70 degrees and 40 degrees. Jack says the triangle is equilateral. Jack, mate, you've got your new bike, but you've not got any understanding of triangles. This is not correct. But the question is not saying, is he right? He's telling you, explain why Jack is not correct. What you'd have to do in here, guys, again, you'll do it in words, okay? You'd have to explain that in an equilateral triangle, all the angles are 60 degrees. So we have 3 lots of 60 degrees. The angles have to be equal. And you can say, in Jack's, they're not. Jack said 70 and Jack said 40. And you could work out the other one because, you know, angles in a triangle add up to 180. We've done a video on that, so you can watch that on our channel. 70 plus 40 is 110, so it would be another 70. No. You could even say his triangle has 2 angles the same, and his is an isosceles. Okay, so you could write that out for me. Here's an isosceles, not equilateral. Lots of proof, lots of evidence. That'll make sure you get the mark. Question 15. A shop prints designs on t-shirts. They use this formula to work out the price of a design. So this is the formula. What is the price for 3 colors? Well, let's take a look. Price is 60 pence multiplied by a number of colors. In our case, 3. So 60 pence times 3. 6 times 3 is 18. So 60 times 3 is 180 pence, which I know is the same as £1.80 plus £1.25. So £1.80 plus £1.25, we're going to get very carefully with the decimal, because the decimal changes everything. It'd be a very expensive shirt. Otherwise, it's not going to be a 2 there, is it? It's going to be 0, because 8 plus 2 is 10. And we can exchange over there. 1 plus 1 plus 1 is 3. That says £3.05, I promise you. In the test, if you're not sure, just make it really clear. Write it underneath. £3.05. Don't get trapped. Okay? Don't make the marker have the option to not give you the mark. £3.05. I'll even put the units in again. Next one. Amina has £5 to spend on printing a design. What is the greatest number of colours that she can have in the design? Guys, think about it this way. £3.05. So 3 colours cost £3.05. How do we know that? We just worked it out. Every extra colour, if we look at this part of the equation, every extra colour is another 60p. So 4 colours would be £3.65. 5 colours, same thing guys, add another 60p, would be £4.25. 6 colours, you guessed it, add another 60p, would be £4.85. Now, if we added another colour, we'd add another 60 pence, and we'd go past £5. So this is the maximum. She can get 6 colours, and if you wanted to test it out and make sure, it does say show your method, so you can do this. You can put 6 colours back into the equation. So 6 times 60 is £3.60. And then you've got to add on the £1.25 that you add on to everything in the formula, which is right here. And if you do that, you get the same £4.85. Cannot afford another colour. 6 is the maximum. Next question, question 16. We're doing really well. A book has 276 pages. Amina has read 1/3 of the book. How many pages are left? Classic reasoning stats problem. In the arithmetic, it would just say, find this fraction of an amount. Not here. Guys, I promise you, just doing a quick bar might help. Because think of it this way. She's read 1/3. So I'm going to split this. Imagine it's the book in 2/3. She's read this part. How many pages are left? She's got all of this left. So if I was to write that as a fraction, what I'm really doing here is finding out what's 2/3 of 276. Now we know that, honestly, this question becomes quite easy. So we divide by the denominator. So we're going to take 276 and we're going to divide that by 3. 3's into 2 don't go, so exchange. 3's into 27 are 9. Exactly. 3's into 6 are 2. So we know that each third is 92. So the answer is 92, right? Wrong. We don't want 1/3. This is what 1/3 is worth. We want 2/3. So she has 2 lots. I can't write that. Let me write this again. I have 2 lots of 92. Again, you might be able to double in your head. I'm going to write this just to make sure. It's 184 pages. So for this question, a classic example of how we can make something trickier than arithmetic by embedding it in a word problem and making you really work out. We're not just going to see 1/3 and work out 1/3. We have to read the question, visualize it. The actual question was 2/3 of 276. Question 17. On a dice, the sum of the dots on opposite faces always equals 7. That is true. If you have any board games at home, go and grab a dice. You can have a look. The opposite sides always add up to 7. Draw dots on the 3 empty faces so that it could fold up to make a dice. Well, let's think about this. This is a spatial reasoning question. Okay, so it's going to be hard for me to draw this. But first thing to notice, this 6 needs a 1. Now it's touching that side. Here's the thing about opposite sides on a dice. They don't share any edges. 1, 2, 3, 4. None of this edge is shared with the opposite face. So here, think about this 6. It shares an edge here. And when it folds over, it will share an edge there. So the 6 shares an edge with these 2 blanks. That means the only other option for the 1 must be down the bottom. Now let's think about the 4. The 4 needs a 3 to be its opposite. Well, it shares an edge with this square. So this 4 can't have a 3 here. So the 3 must be this side. And now finally, the 2 is missing its 5. There's only 1 space left. You've got to do this much neater than me. But the 5, therefore, must go there. Work systematically. It's all about you realizing, okay, faces don't touch if they're opposite each other on a cube. And then you can work it out from there. Question 18. This is a diagram of a vegetable garden. It shows the fractions of the garden planted with potatoes and cabbages. 2/3 are potatoes, 1/4 are cabbages. The remaining area is planted with carrots, which we can see here. The question is asking what fraction of the garden is planted with carrots. Did I say painted? Oh dear, I meant planted. Good job this isn't an English test. What fraction of the garden is planted with carrots? Well, we've got to think about it like this. The whole garden is 1. We have 2/3 are potatoes and we have 1/4 are cabbages. So we need to take away 2/3 and take away 1/4 to see what's left over. But guys, like I always say, and I said this in arithmetic before, when the denominators are different, we have to find a common denominator. So we can't work with thirds and quarters. They don't work together. Let's make them both the same. Now, 3 times 4 is 12. That means I can change both denominators to 12. To keep 2/3 equivalent, we did 3 times 4 is 12. So we do the same to the top. We're going to do 2 times 4 is 8. Then for quarters, to keep it equivalent, that's meant to be a 2. We did 4 times 3 is 12. Do the same to the top. 1 times 3 is 3. So we actually got 1 whole, take away 8/12, take away 3/12. Well, again, I'm going to change 1 whole into 12s. That way, it's such a simple question. It becomes like a year 4 question. What's 1 whole in 12s? Well, it's all of them. All 12 12s make a whole. So we have 12 12s, take away 8 12s, take away 3 12s. Now all the denominators are the same. We can just focus on the numerators. 12 take away 8 is 4, take away 3 is 1. That is 1/12 of the garden with carrots, and you can write that down just there. What a classic reasoning question again. This paper has been a tricky one so far, but it's maths you can all do. If you're in year 6, you would have practiced this maths a lot. It's just tricky trying to work out exactly what to do. So practice really does make perfect, guys, for these questions. Question 19. 33,630 is the same as or equivalent to 354 multiplied by 95. So it uses multiplication to complete the calculations below. Now, when it says this, you don't have to do any more formal methods to figure out the answer. Let me show you what I mean. 345 times 95 is this answer. So 345 times 9.5, this is 10 times smaller. So we've just taken 95 and making it 10 times smaller. So now we need to do the same to the answer. Make this answer 10 times smaller, and you'll get 3,363 as the answer. Next one, we have 3,540. This time we've made this 10 times bigger. So if we make one of the numbers on this side 10 times bigger, we have to make the answer 10 times bigger. So the answer becomes 336,300 because we add the extra placeholder in this time. Remember to always go back to the original. Next one, 3,363 divided by 95. Now, here's something that I want to show you here. It's really important because during this question, we would actually get 33,630 divided by 95. If we use the inverse, we'd get 354. But look, we've made this 10 times smaller. So if we make this 10 times smaller here, we've made this 10 times smaller to get 3,363. So we have to do the same to our answer. We need to make this 10 times smaller. And we would actually get 35.4. Now, if we actually sat here and tried to work all of these out with decimals, we might be here all day. We might get confused. But we can use 10 times bigger, 10 times smaller to help us compare answers. In the same basic way that we know 6 times 4 is 24, then we know, don't we, that 60 times 4 is not 24, it's 240. So that's the same logic here, but it's taken to the highest level. So really, really tricky levels with decimals as well. Question 20. In March, Ken collects 2, 3, or 4 eggs each day. So it could be any of them. In the first 20 days, he collects 57 eggs. I'm going to write that down straight away. There are 31 days in March. So I'm going to, again, straight away, I know there are 11 days left. So this is after 20 days. There are 11 days left because 31 subtract 20 is 11. There are 11 days left. What is the greatest number of eggs Ken can collect in March? Well, what's the greatest number of eggs he can pick in one day? Well, that's 4. So if there are 11 days left, and let's say he goes for the maximum, 11 times 4 each day, that's 44. We can add that on to 57. I'm really writing my numbers backwards here, my goodness. 7 plus 4 is 11. 5 plus 4 plus 1 is 10. We get 101 eggs. That's the maximum. So that's considering he goes for the maximum every day. We've worked out there are 11 days left. We've done 57, what he did so far, plus the 44 eggs that he could in the next 11 days. We get 101 eggs. Woof! We are nearly there, guys. 21. Jack finished a sponsored run in 53 minutes and 25 seconds. Ali finished 3 minutes and 50 seconds after Jack. So that means she took longer. So we're going to add on 3 minutes and 50 seconds. So first thing, add on the 3 minutes. 53 minutes and 25 seconds becomes 56 minutes, 25 seconds. Now the tricky part, we're going to add on the 50 seconds. Now what's 50 seconds really close to? Yeah, it's really close to 60 seconds, which is a minute. So I'm going to add on another minute here. I'm going to get to 57.25. But there's a problem. This would be adding on 4 minutes in total. No, I need 3 minutes and 50 seconds. So to correct that, I'm going to take off 10 seconds right now. So 57 minutes and 15 seconds. So all I did there was, instead of adding on 50 seconds straight away and going past a minute, it gets confusing. I added on 1 minute and then took off the 10 seconds to correct it. Layla finished the run 8 minutes and 45 seconds before Jack. That means she was quicker. So again, let's write down Jack's time here, which was 53 minutes, 25 seconds. I'm just going to do it with a colon in the middle. 8 minutes and 45 seconds. So for this one, I'm actually going to take off 9 minutes. So take off 9 minutes and I get 44 minutes, 25 seconds. But of course, the question didn't say take off 9 minutes. It said 8 minutes, 45 seconds. So to correct this, I'm going to add back on 15 seconds. That 15 seconds comes from the fact that I just took away too much, because I took away 15 seconds too much. Instead of 8 minutes 45, I took away 9 minutes. So now I'm going to add back on 15 seconds to her time to correct it. 25 plus 15 is 40. So her time was 44 minutes and 40 seconds. What a brilliant time. She absolutely smashed him. So awesome. What I did there, guys, was I used mental strategies, and something we need to practice is look at near numbers and then correct. So if I'm adding 98, you can add 100 and take away 2. If I'm adding 59 seconds, add 1 minute and then take away 1 second. Adding 1 minute and taking away 1 second is way easier than trying to jump past a minute to 59 seconds. It's just too tricky. So there's a nice technique there for you guys. And we are finished. I thought there was one more question. My goodness. That is the final segment of this series of the 2018 maths papers. Guys, I hope you found them really useful and they help you to understand what's going to come up and revise and do all the good stuff. I'll see you again soon for another series. Have a good one.